Idris Data Science Infrastructure. So this is a bit of an egocentric talk. I'm going to be talking about everything I've been doing for the last 8 months. This isn't about how we're going to be doing data science directly. It's going to be about the infrastructure surrounding data science. So this is how we talk with the businesses, for example. And so that's why I put the subtitle here, because sometimes we do have to consider the real world. This work is supported by the NCSC. So I'm starting with the question of how do we want to do data science in Idris? So it is nice to imagine that we get our data in some beautifully structured format and that we just go ahead and directly do our data science on it. But in practice, it's very rarely that nice. So I've got one possible workflow here. We receive our data from the business, probably in a spreadsheet. Most businesses do use spreadsheets all over the place, and lots of systems have spreadsheet exports. So that's why I went with this. For convenience, we're going to assume LibreOffice because that's relatively easy for us to parse. We then parse the spreadsheet in Idris, so there is still some parsing that you're going to have to do when you do your data science. We then get our data out of the spreadsheet, so we then actually do our data analysis in Idris. That's an exercise left for the reader. I'm not going to cover that here. We're then going to want to present our results back to the business. And there's two ways I'm going to be thinking about that. One is going to be an interactive and pretty way. So this will be some sort of presentation that you're giving, and also reporting in a rich text file. So this will be some sort of document that you give to them and say, here you go, here is the results of our data science. Again, we're going to be assuming LibreOffice for this, just for convenience. So the way we've decided to go about this was 3 main points. We're going to create a Jupyter kernel for Idris, and the reason we're doing that is so that we can do the presentation will be in Jupyter kernels. We're going to create a Vega Lite plugin for the Jupyter kernel. Now, for those of you who don't know, Vega Lite is a graphing DSL. So we're going to be using that to make it very pretty. And then we're also going to be having some sort of I/O with LibreOffice files so that we can read our spreadsheets and that we can write our completed text documents back afterwards. So I've got a little demo, and no, that's the wrong one, that's this one. So here is a Jupyter notebook, and this is an Idris Jupyter notebook. So Jupyter notebooks more closely resemble command lines than it does the file-based syntax. So we are going to be using the REPL syntax here. We can define things just like we do in REPL. So we're defining a function here and then calling it, and there's the result of that function. We can use other REPL features, so doc we can use here, and it prints out the documentation for SNOC list here, including the syntax highlighting that comes with it. We don't have syntax highlighting on this bit yet, that's on the to-do list, but we do have syntax highlighting on the output because we're just taking the version that gets sent to the command line and just printing it out here. We can import modules, we can do things on things in the imported modules. We can import local modules as well. So in the directory I'm running the Jupyter kernel from, I've got a module called MyModule, and that's the other thing you saw briefly when I switched to the wrong screen. And that's got a few functions in it here. So I've got parse some data here, and what this does is it takes a file name and for a LibreOffice spreadsheet, and it extracts the data in a particular format. So some data here is just calling that function on a local spreadsheet that I've got, which has just got a couple of columns of data, which I'll show you in a moment. It also includes the myBarChart function, which I'm going to be talking about later when I get to the Vega Lite stuff. And then this is just wiring it all together so that we can display our Vega-like graph just like that. And this is actually using the data from a spreadsheet. It's all going through pipeline to pop out the other end here. Yes, and if you are using local modules, then you'll need to define an iPackage file in the same directory you're running the Jupyter kernel from. That is just a relatively standard Idris thing. So I think that's everything I want to show in the demo. So let's go back to the slides. So there's multiple ways of making a Jupyter kernel. We wanted to do something in Idris, and the reason we wanted to do that was so that if someone wants to contribute to the Jupyter kernel, they only need to know Idris. They don't need to know Python. They don't need to know any of the gory details about how we're communicating with the kernel. They just need to know Idris. So there are a few things that we do want to add in the due course of time. It's relatively minimal at the moment. So I mentioned semantic highlighting when I was showing the demo. That's something that would be nice to have at some point, and various other things as well. So integrating it with the language server as well, I think, was another. So yeah, there are multiple ways of doing a kernel. So we decided to create a Python backend for Idris. So then we could FFI into a Python library to create Jupyter kernels from Idris, and then I need to know the details of how that Python library works, but anyone else who's working on the kernel, they don't actually need to know anything about that. They only need to worry about the Idris. So there were other options as well. We could have just interfaced with the ports directly, or alternatively, we could have gone with the C++ library. We went with the Python backend because we think that'd be useful more generally. And a lot of data science stuff is written in Python, so it does give us a little bit of compatibility as well, which will probably be quite nice down the line. So that's what we went and did. We went and made a Python backend. We can call Python functions using the FFI, so that's something like this here. And we also provided a library of bindings for Python's standard library, so that's this bit here, import Python, and then we can use some of the standard Python bits from within Idris. So we can use the Python print function, we can use Python lists, and it all works just like that. So rather than create the Python backend from scratch, we decided to base it on the Refse backend. The idea of this was to speed up development. However, there were a few problems with Refse at this point. So this is just a list of things that I've done over the months to bring Refse up to the standard we needed to be able to work with the Jupyter kernel. A couple of notable things were there was a seg fault in Believe Me, and Believe Me is used in quite a few FFIs, so this caused quite a lot of seg faults all over the place. And yeah, a lot of support for string, for maths, buffers, clocks, string iterators, command line arguments, this, that, and the other. And I suppose the last one worth noting is the ability to extend Refse, which I did talk about before in another talk called Extending Refse. So all of this was sufficient for getting the Jupyter kernel to work, but there is still an issue with tail recursion. And I think that if we manage to fix this bug, then we can actually self-host Idris, both in the C backend and the Python backend. This means that we could actually then put Idris on PyPI, which means that you could just do pip install Idris and have that work. So that would be another option for the package manager wars that's going on at the moment. So that's it for Refse, and by that for Jupyter Kernel. So on to Vega Lite. So this was a plugin for the Jupyter Kernel. So it's actually in a separate library, so it's not too tied into the Jupyter kernel, and actually other people could add other plugins as well if they were so inclined. So Vega Lite uses JSON to define its graphs. I've drawn an example here of a simple bar chart. This is very similar to the bar chart I showed you in the demo. But JSON is a bit fuzzy for our purposes. If we're programming in Idris, we're going to want our types to be a bit more meaningful, a bit more semantic. So thankfully, Vega Lite does have a schema. So we're not just manipulating raw JSON, but JSON schemas are written in JSON, and we want something in Idris. So I actually wrote a JSON schema parser, which generates Idris types which match the schema. So this is moving towards semantic types, but there are other restrictions as well, because we can't express everything in a JSON schema that is the restrictions we want to impose. For example, you can't enforce that the fields here are actually available in all of the values here, and that we've got the right fields and the right values, and we can't enforce that at a JSON schema level. That's something that we've got to add on top of that. So actually, if I refer back to this is the MyModule module that we imported into the Jupyter kernel earlier. And so we can see here that this is quite a big specification. So this is taken straight from the JSON specification, and it would be nice to have something a bit more smart on top of that, get rid of most of these nothings here. And actually, default values for records was actually added to Idris this morning, so I plan to actually make that a little bit nicer relatively soon. And one thing I will note is that because we're working in Idris, we can add dependencies to our type signatures. So here we've got a description, a list of names that we're using for the bar charts, and then a list of the values that we're using for the bar charts. And in a JSON schema, you can't enforce that they're the same length, but we're working in Idris, so we can use vectors, and we can say right here that they are the same length. And so this is another thing that we are putting on top of the JSON schema that we can't express in that way. So I think that's everything I want to talk about for the graph plugin. I did want to briefly mention a bit more about the JSON schema tool. So here's a quick example for that. There's a JSON schema on the left here, which is just for a list of films. So our top level object is an array, and it's a list of referring to these films. And then in our definitions, we say this is what a film is here. And then this generates this Idris code on the right-hand side. So this is a film, and then our top level object is a list of film here. The tool can also change the name of the type generated. I called it My Films here, and it can also set the name of the module that it generates as well for convenience. So I will also note that title is required here. So title is a string. However, year is not required, and so that's only a maybe type. So that's just another nice thing that we can do there. Moving on. For the last section, I'm going to be talking about LibreOffice. So LibreOffice it uses the ODF file format, and ODF files are just zipped XML under the hood. So we went and made an XML library. So just a basic library to parse and manipulate XML types. It's based on the odd alternating list type, which we're viewing here as a free monoidal extension. So what we mean by that is that the contents of an XML element is alternating between character data and other XML elements, and that we can concatenate two contents together just by squishing together the innermost character datas and then just listing everything one after the other. This induces a monad. In fact, it induces a couple of monads, but we're only going to be focusing on one of them here. And so what this function at the bottom here does is it goes through each of the elements in another element, ignoring all the character data, and doing this recursively. And if it's an emphasize tag, then we just dump out the contents. And if it's otherwise, then we leave the element unchanged. And so what that does is it changes this XML at the top here. It just removes the emphasize tag here, and we get lorem ipsum $sitarmet without the emphasis tag, and we keep all of the character data. So once we've got that in place, we can start with the ability to read spreadsheets. So I've got a read ODS function here, and so that does a bit of I/O and searches for the ODS file spreadsheet of that name, and if we get it, we can then find a sheet on that in that file, and we can then select a range of cells within that sheet. We can then manipulate those cells with standard Idris functions. So if I go back to the MyModule function from earlier, the parse some data function, which I briefly glanced over, so that uses read ODS here, and then we're parsing each of the cells very naively in this case. I'm saying that there's a fixed range that we're looking at, and I'm using a maybe type, so if it fails parsing, I'm not doing any clever error messages or anything, I'm just failing immediately. And I'm just saying, well, I'm expecting everything to be in this format. And because it is, then it quite happily returns the result value there. Yeah, so that's how we get values out of spreadsheets. We can then go the other way, as it were, and fill in values and modify our text files. So read ODT template here is very similar to the read ODS from the previous slide, but it returns a dependent pair here. And the value on the left is the free variables in the template, and then the value on the right is the actual template object, which is indexed by the free variables. So this line here, if our spam.odt file doesn't contain exactly the from name and to name variables, then this pattern here will fail at runtime and we'll instead get this pattern here. While this is a runtime check, it is earlier than most templating systems, which either check the variables at render time, so that would be down here, or they don't check the variables at all. And if you miss out a variable, then you just end up with an output that still has the template variables in, which is less than ideal for most circumstances. So if Idris had type providers, it doesn't have it yet, but it might do at some point. We could actually move the check in the first line to a compile time check rather than a runtime check. But that's for another day. So yeah, then in the render in the middle here, if we miss one of these variables out, or if we misspell them, then this bit here will be caught at compile time because it doesn't match the earlier values that we expect in the template here. We're using dependent types for this, and so that's quite nice security there to make sure that we actually use all of the free variables in the template. And then this spits out an ODT object, having done all of the substitutions. We could equally use the substitute and done functions, though I've not included them in this example, which substitute the variables one at a time and then convert the completed template into an ODT object. But this render function does them all at once, which is convenient for example like this. We then use the update ODT method to do an in-place update of our XML document with all the substitutions. The values that we're substituting are actually XML contents. So this is character data here, but we could also interleave other XML elements if you happen to know what the representation of some object you want to inject into your document is. So this allows you to inject rich objects, not just raw text. And that's everything. So in this project, I've added quite a few things. So that's them listed here. In roughly chronological order. And yeah, that's it. Any questions?
Thanks a lot. That was really good.
The graphic was printed using an IO expression. Yes. So let's go back to there we go. So the graphic itself is represented using a VegaLite object, and that can potentially be pure. But then actually displaying that VegaLite graphic in the notebook does require printing to the console, at least from the perspective of the kernel. So that does require I/O. Is parsing quick enough? Can we imagine lazily parsing the file so that, e.g., after selecting sheet 1, we only parse the data for that and simply forget about the rest of the ODT? So sorry, ODS, I assume you mean. So ODS files, they actually tend to be quite small in terms of content. So the parsing was quick enough in my experience. I suppose we could lazily parse it because each of the sheets is stored in a separate XML node, but that would require some sort of lazy XML parsing, and I haven't done anything like that yet. Are these results published somewhere, and what is on the roadmap? So everything I've shown you is available on GitHub. Each of the projects has a separate repository. I will post a link to all of them after the talk. What's on the roadmap? So this is actually the last thing that we had to do in the project. So at this point, for the remainder of the project, we're probably going to be revisiting things where we said, I'll do that later, and we've now reached later. Yes, and OHAD is planning all sorts of things.